Okay, so here we have diluted 240 milliliters of 32% solution to a 12% solution. And we want to know how much saline needs to be added here. So again, our first step is going to be to find that dilution. So we've got 12% is the new percent, the diluted percent, and 32 is the concentrated percent. If we reduce those, both once again will divide by 4, gives me a 3:8 dilution. So our dilution is 3:8. So that means we have the 3:8 dilution. The 240 milliliters goes where? On top. And we cross multiply and divide. 80 times 240 divided by 3 is 640 milliliters. That's the amount of the new solution we need. How do we know how much saline to add? Perfect. The difference must be saline. The old volume was 240. The new volume is 640. We subtract those to get a difference of 400 milliliters. That's has to be made up with saline. So you can see that ratio of percents of concentrations is equal to the dilution ratio. And that's very powerful. Now there is a shortcut for doing this. Looking at this problem here, before we did the dilution, we had 240 milliliters of 12% solution. After the dilution, we had 640 milliliters of, oops, I had that wrong. It was 240 milliliters of 32% solution before. After, we had 640 milliliters of 12%. So we went from a starting amount, 240 milliliters of 32%, to an ending amount of 640 milliliters of 12%. Going back to what we saw earlier today and what we saw last unit when we were doing our mixture problems, the amount of active ingredient here should not change because we're only adding water or saline. It's a neutral solution with no medicinal value. So before, we have 0.32 times 240 milliliters. That is 76.8 milliliters of active ingredient. After, we have 0.12 times 640 milliliters. That better be the same, but let's double check it. 0.12 times 640 should also be 76.8, and it is. So 76.8 milliliters of active ingredient. So we have something called a concentration adjustment formula. Or sometimes just called change in concentration. And what this formula says is, as long as all we are doing is adding some sort of a neutral substance, saline, sterile water, whatever, as long as we're only adding stuff with no medicinal value, C1 times V1, 1 just means the first, So the first concentration times the first volume will equal C2 times V2. The 2 there just means the second. So will equal the second concentration times the second volume. So for the problem we just did, rather than going through the dilution and finding the amounts that way, we could have done 0.32 times 240 is our initial concentration. Equals 0.12 times V2 is going to be our final volume. So 0.32 times 240 is 76.8 equals 0.12 times V2. And we would solve that by dividing by 0.12. 76.8 divided by 0.12 is 640. That would be in milliliters. So our second volume would be 640. Now the nice thing about this formula here is because both of these concentrations, there's a concentration on each side, I should say. We don't have to even express the concentration as decimals. This would have worked out if we had left that as 32 instead of changing it to 0.32, as long as we did the same with the 12. So I could have done 32 times 240 milliliters equals 12 times my second volume. The difference is this is going to be 7,680 equals 12 times V2. We would have still divided by 12. Now it still came out to be 640. Numerically, I know this one is simpler because we don't have the decimals to deal with in it. To me, conceptually, this one makes more sense because by changing them to those rates, to those decimals, what we are getting here really is the amount of active ingredient. If I'm in a hurry, I just do it this way because it's simpler, as I said. Less keystrokes on the calculator or whatever. But really, as long as you remember that what this number is here is really the amount of active ingredient. And you know that this one here isn't, it's just the decimal points are off. I mean, you could get it from there, but it's not right. For sake of calculation and ease, I'm going to say this is the formula over here that I generally will use. So let's say we want to, we have 300 milliliters of 84% solution. We dilute it to, let's see here. Let's say we dilute it to 1,000 milliliters. Find the new concentration. So I usually put the initial or the starting on the left side and the final or the ending on the right side. So we started with 84% times 300 milliliters. Now again, you could do 0.84 times 300, it doesn't matter. On the other side, we don't know the percent, so that's X times 1,000 milliliters. So to solve this, we're going to multiply the 84 times 300. Ooh, that's 25,200. And then, of course, we're going to solve the equation by dividing by 1,000. So 25,200 divided by 1,000 is 25.2. That is a percent. So that's been diluted to 25.2%. We might ask, how much 42% solution is needed to create 480 milliliters of 7% solution. So this time we have the 42%. We do not know how much of it we have. We're diluting it to 7%, and we have 480 milliliters of the 7%. Now, I haven't been putting the units in here. It doesn't matter as long as the units on the right side are the same as the units on the left side. So both of those are going to be in milliliters. So to solve this, we would simply do the 700 times 480, or sorry, 7 times 480 is 3,360. And then solve for x by doing what? Divided by 42. So x equals 80. So it requires 80 milliliters. What is the new concentration if we add 180 milliliters of NS to 120 milliliters of 36% solution? So we started with the 36% solution. So that's 36 times the 120 milliliters. On the other side, we don't know the concentration. What goes in here for the volume? Yeah, we added 180 milliliters to the 120 milliliters that was already there. So yes, that'll be 120 plus 180, or 300 milliliters. So now we have to do that 36 times 120. Which is going to give us 4,320. And then finally, we solve that by doing what? Divided by the 300. So X is 14.4%. Unit concentration. What do you think? Not terrible? So let's look at this from the other direction. How much normal saline should be added to dilute 240 milliliters of 63% solution to 42%. So again, we start out with the 240 milliliters of 63% solution. So 63 times 240. On the other side, this time we know the concentration. We want the 42%. We're looking for that volume. So we'll do the 63 times 240. 15,120. Then, of course, we divide by the 42. $360. Is that our answer? Well, 360 is describing the amount of the 42% solution. But we were asked, how much saline do we need to add? The 42% solution requires 360 milliliters. The 63% solution was only 240 milliliters. The difference has to be made up with the saline. So we subtract there 360 minus 240 is 120 milliliters of NS. So that's our answer for that one. Sure. Continue. So I'm going to have you guys answer a few here. Let's start out with this one. What concentration is created when 480 milliliters of saline is combined with 360 milliliters of 42% solution? I'll give you a couple minutes to figure that one out. So for this problem, we start out with the 360 milliliters of the 42%. So it's 42 times 360 on the left side. On the right side, we don't know what our new concentration is. So that's what we're looking for. I'm going to use C2 there just to keep knowing that's a concentration. The volume of that is the 360 milliliters of the 42% plus my 480 milliliters of saline that I've added. So over here, I just will go ahead and multiply the 42 times 360. It's 15,120. On this side, 360 plus 480 is 840. So now we solve by dividing by the 840. You get 18% solution. Is our new concentration. How many of you got that? Sort of? Well, let's look at this. How much saline should be added to 120 milliliters of 65% solution to dilute it to 39%. I'll give you a couple minutes to try that one. So here, once again, we're starting out with 120 milliliters of 65%. So it'll be 65 times 120 on the left side. Now we're diluting it to 39%. So on the right side, we got the 39 as the concentration times, I'm going to put that times V2. My volume is what I'm looking for. So I'll combine 65 times 120. Is 7,800. And we solve it by dividing by 39. Should give me 200 milliliters. Now looking at that, is that my answer? No, what do we have to do? Perfect. We have to do 200 milliliters minus the 120 that we already had. The difference must be the amount of saline added. So we added 80 milliliters of saline. Wonderful. Okay, so that formula saves us a lot of steps over just going through and doing the dilutions. So the next step I want to look at is I want to look at these concentrations themselves and how they're calculated. We've been throwing that out there that it's a 65% concentration or 12% concentration. Well, what does that really mean and how is that calculated? Well, there are actually 3 different ways that those concentrations can be calculated. The first is what's called a volume in volume concentration. The notation would be V in V. This type of concentration, we are just looking at volume of the serum or the concentrate over the total volume of the solution. So let's say that we have let's say we use 40 milliliters of pure hydrogen peroxide. To create (600 milliliters of solution. The volume and volume concentration here is going to be the 40 milliliters over the 600 milliliters. And to change this into a percent, of course, it's going to be the percent over 100. So you just cross multiply and divide. Of course, the milliliters cancel out. 40 times 100 divided by 6. Is going to be 6.67%. Excuse me. So that is a 6.67 or 6 2/3% concentration. Now, we have to be very careful with volume and volume solutions. When we measure the volume of what we're adding in that solution. For example, let's look at a saltwater solution. A volume and volume solution is not additive. So if I add 40 milliliters of salt to 400 milliliters of water, we will not get 440 milliliters of solution. The reason for that is that when we dissolve, when we actually have a true solution where one substance dissolves into the other, that first substance, that what's dissolving, disappears and it hides in the small gaps between the particles of the solvent. In this case, the salt will hide between the particles of the water. So that volume might increase from 400 to like 415 or so, but it will not increase to 440. So when we're dealing with a volume and volume solution on the scientific side, from the chemistry side of it, we cannot say that this is 400 milliliters of salt or 40 milliliters of salt and 400 milliliters of water. That's a 40 and 440 you can't use 440 for a total because it doesn't quite work that way. So when we're dealing with a volume and volume solution, we must be given the total. We can't just add the substances together. Now that's only as for a solution. There is something called a suspension. In a suspension, the volumes are additive. The easiest way to tell the difference between a suspension and a solution, just by looking at the label on the bottle. Is a little instruction, shake well. Have you ever seen a medication where it looks like it's thicker on the bottom and thinner on top? Pepto-Bismol is a prime example of it. That is not a solution. It is a suspension. You mix that up and it is well mixed and it looks like it's going to stay that way, but over time it does slowly separate. The medication actually slowly settles to the bottom. In a suspension, that volume is additive. Now, this textbook does not make that distinction between suspensions and solutions. So in this textbook, just whenever they say you're adding a certain amount of medication to a certain amount of water, assume it's a suspension so that the volumes are additive. But in practice, you do have to be careful with that. So the next type of solution we have is called a weight in weight solution. This one is a little simpler because weights are always additive. By the way, since when we use metric units, we're not actually using weights. We're really technically using masses because we're going to be using grams and milligrams and whatever. So in a weight in weight solution, like I said, weights are always additive. So if we have 80 milligrams of medication, I'm just going to say of serum, in 500 milligrams of total solution, the concentration will be 80 milligrams over 500 milligrams equals, to find our percent, blank over 100, percent over 100, 80 times 100 divided by 500 is 16. So that solution would have a 16% concentration. That would actually be read as a 16% weight in weight concentration. Since this is a weight in weight concentration, we can say if we combine 60 milligrams of serum with 420 milligrams of saline, find that concentration. Well, because this is weight and weight, we can do 60 milligrams as our medication and 60 plus 420 is our total weight. So that, of course, is going to be 60 over 480. To make that a percent, of course, it's blank over 100. Cross multiply and divide. That's 12.5 out of 100. 12.5% solution. So with its a weight and weight solution like this, we can ask how much NS should be combined with 25 milligrams of serum to create a 5%. That W/W stands for weight and weight solution. Well, the way I would do this is I would just find the total volume. 5%, of course, is 5 out of 100 equals the 25 milligrams of serum is going to go top or bottom. The 5 and the 5%, remember that percent, the top number is the amount of serum, the bottom number is the total. Total weight in this case, I should say. So the 25 milligrams has to go on top. We will cross multiply and divide to get that this must be 500 milligrams. What do I still have to do? There we go. 500 milligrams total weight minus the 25 milligrams of serum means that the rest of it had to be made up with the saline. Our final type of concentration is called a weight in volume concentration. And to make this one work, we have to go back to our last unit and review just a little bit. In the metric system, 1 gram is defined to be the mass of 1 cubic centimeter of water. Well, 1 cubic centimeter is equivalent to 1 milliliter. I don't know why I made my 1 look like a 7 there. Try that again. 1 milliliter of water. Most of the fluids we use for medication, normal saline especially, is pretty much identical to water. Most of the solutions we use in medication have a density similar to that of water. Glycerin's a little thicker, alcohol's thinner, less dense. But saline is basically just a purified water, sterilized water. So it will have this relationship of 1 gram equals 1 milliliter. So when we are doing a weight in volume solution, the weight is going to be in grams and the volume is going to be in milliliters. That's confusing to some people because they see that the volume's in milliliters, they think the weight should have to be in milligrams, but that's not how it works. So if we have 32 grams of medication, of serum, in a 400 milliliter solution, our weight in volume concentration is 32 grams over 400 milliliters equals blank percent over 100. And we cross multiply and divide. 32 times 100 divided by 40, or 400, is going to be 8 out of 100. This is an 8% solution. If we are given that we have 200 milligrams of serum in 50 milliliters of solution. A lot of people look at that and say 200 milligrams and 50 milliliters, that's a pretty high concentration. But remember, 200 milligrams is really how many grams? 0.2. Remember, there's 1,000 milligrams in a gram. Or if you're looking at the chart, you got grams, decigrams, centigrams, and milligrams. It is 3 spots to the left on the chart, so the decimal point has to go 3 spots to the left. 0.2 grams. And when you express it that way, that's 0.2 grams in 50 milliliters. Blank over 100 for our percent. We cross multiply and divide. 0.2 times 100 divided by 50, or by 500, is only 0.04%. So that is a pretty small percent. Any questions? Okay, that is pretty much everything for this week. So let's give you some homework to work on. We covered it last week, but it wouldn't hurt to go back over some of the more difficult problems. Page 130 to 132. 1 through 37, the odds. And then where we started today, page 134, 1 through 11, the odds. That's adjusting that concentration of the solution with the dilution. So if you have a 16% solution, you take it through a 1 in 8 dilution, it becomes 2%. Page 138, 1 through 17, the odds. That's that change of concentration formula or concentration adjustment. C1V1 equals C2V2. And finally, then, the stuff on these concentrations, page 146, 1 through 17, the odd. You guys actually fall pretty good this year because spring break has a couple of weeks between spring break and Easter. In the last 2 springs, we've started this unit, we've had spring break, we've come back, we've had 1 class, then we had Good Friday off for Easter, then we've come back and had the exam. So you guys actually, we will come back from spring break, we will have 1 lecture and then the exam after spring break.